Hello, everyone, and welcome to our webinar for tips for student success with data. We'll begin in about 2 minutes. Please check your settings and let us know that if the webinar isn't working correctly for you, and we would be happy to help you out. Thank you. Welcome. We're so happy to have you here for our webinar, Tips for Student Success with Data. Before we begin one last time, take a moment to make sure the webinar is working properly on your computer or device, and we will start. So hello, everyone. We're glad to have you here. And here we go, tips for student success with data. We know this is a topic that everyone is wanting more information and help with, and so we're so excited to have our panelists here today. So my name is Leah Watson. I'm the marketing manager for Sage Stats at Sage Publishing, and today we have two excellent speakers, Lynda Kellam and Diana Aleman. And before we start, we're going to have a couple of polls that we would love for you to let us know. We want to know more about you so our speakers can really speak directly to you. And we also have a winner. So we said we would pick one winner for a $100 Amazon gift card. And I'm happy to announce that that winner is Carrie Walton. So Carrie, thank you for signing in, and we will make sure we connect with you to get you your $100 Amazon gift card. So take the poll, let us know what type of library you work at. And it looks like we have academic libraries for the win. I think we're at 100% right now for academic libraries. And now I'm going to let you know a little bit about our speakers. Our first speaker is Lynda Kellam. She's the Data Services and Government Information Librarian at the University of North Carolina at Greensboro University Libraries, and she's the Assistant Director of the International and Global Studies Program. She is the co-author of Numeric Data Services and Sources for the General Data Librarian and co-editor of Databrarianship, the Academic Data Librarian in Theory and Practice. And she has presented extensively on data services. Our next speaker is Diana Aleman, Assistant Editor on Sage Stats and U.S. Political Stats, which simplifies the statistical research process by providing ready-to-use statistics on the social sciences to students and faculty. She enjoys metadata challenges and wrangling raw data files into workable formats. Thank you both for being here.
Thank you.
If you have any problems with audio or viewing during the webinar, please use the Q&A box at the right hand of your screen, and one of our helpful team members will get back to you as soon as possible. At the end of the webinar, we will have some time for Q&A, so please also use the Q&A box to ask any questions to our speakers throughout the webinar. Please also take note of our webinar hashtag, SageTalks, and feel free to ask questions or leave comments there. Without further ado, I'll pass it over to Lynda.
All right, thank you very much. I'm very excited to be here with Sage today, and thank you for inviting me to be here. I don't think I can actually see the chats, but I'm very excited about answering or talking about anything at the end. So definitely feel free to chat as you think up things, and we'll try to address those at the end of the webinar. So I'm Lynda. I've been working as a data services librarian for about 10 years here at UNCG, and I've seen the field change quite a bit over time. Libraries have always had access to data and statistical resources, mostly in print, and some people even have had experience with the file tapes. But one of the things we've seen, especially over the past 10 years, is the increasing use or interest in data because of the increasing access to data. So with ICPSR and all these different data sources that are going online, that are easy to use online, it means that people want to integrate them into their classes and into their research. So at UNCG, more and more of our faculty are very interested in making sure that students have experience with data sets or data resources, but our students don't always come with the necessary skills for being able to do this kind of work by themselves. And so my job over the past few years has really been focusing on novice users, and that's both undergrads and graduate students who come in and who really don't know how to find data or the best ways to find data. And this can range from a variety of things. So one of the things I do a lot is talk to people about finding demographic data for a particular geographic area. There's a lot of interest in our city in doing neighborhood analysis, so looking for demographic or socioeconomic information. But this also can go all the way up to finding large data sets to do hypothesis testing. So it's a range of skills that we are seeing at UNCG, but mostly in our case on the novice side. So discovering data and statistics is not difficult necessarily, but we do need, as reference librarians, to consider the unique aspects of data to ensure that our students have the most success during their research process. So this presentation is a version of one that I gave at ALA annual, but it incorporates ideas that training that I use with my interns and other ideas from articles and blog posts that I've created. And I'm calling it a framework of 4 W's and 1 H of data support or data discovery. And you'll see a lot of this may seem familiar, but hopefully it just gives you a way of thinking or a framework for thinking about data discovery. Once I'm done, Diana is going to talk about tips on using and visualizing data once you've discovered it. So again, if you have any questions throughout, just feel free to chat with us. So of course, the first question, or the first W, is of course what. So what is it you're looking for? So the number one question is always, what type of source does the student need? And sometimes when people, especially some of our newer reference interns, hear the word data, they sometimes will just send the student straight to my office and say, go talk to Lynda. And sometimes they'll jump to the most complex version of that. So they'll jump to a data set, when in reality the student might just need to analyze a few numbers, look at a few numbers. Or in other words, what they're needing is aggregate statistics. So just so we're clear on this is probably a review for a lot of people, but aggregate statistics are the numbers that we most often encounter when searching for the answer to a specific question. So these are the averages, sums, proportions of a particular variable. Excuse me. So for example, what you're seeing on the screen is a table from American Fact Finder, which is the main portal for the American Community Survey and the decennial census. And the table you're seeing here is the number of housing units in the United States by value of housing unit in the American Community Survey's 5-year estimates. So this is a very common reference interaction we would have with students. We talk to them about finding, just these basic aggregate statistics. Now, data sets are the numbers underlying the aggregate statistics. So this is the data set that created the table that we just examined. The numbers here in yellow are not interpretable, or you can't interpret them without a data dictionary that tells you what they mean. So in this case, you can see that number 17 is for 175,000 to 200,000 basically. So in order to be able to make any sense of this, we have to use statistical software to analyze it. You can't really eyeball this because the number of cases in here is so great. I mean, there's going to be thousands of cases, millions in some cases. So you really have to use statistical software to be able to analyze this, which requires comfort level with that. So data sets are useful for anyone who's wanting to go beyond the pre-generated tables and ask more specific research questions or test hypotheses. And to help with student success, we really have to be sure about which resource it is that we need to send students to, make sure if we're finding the right resource to fit their needs and their abilities. If they don't have the ability or knowledge of statistical software, then this is not going to be appropriate, obviously, for them. In addition to, in the what category, is what is the purpose, and this is related to the first one. Do they want to support a particular claim, or are they just wanting to do discovery? Are they looking to find out answers to general questions? Are they wanting to run a regression analysis? Do they want to visualize the data? What really is that purpose that they have? I look at this, usually we'll look at an assignment, of course, and help them understand the expectations. Sometimes I have students who come to my office with very outsized expectations of what their professor is actually asking them to do. So they may be going above and beyond what the professor is really wanting them to do. If you don't feel comfortable negotiating the assignment with the student, though, I would definitely refer them back to their faculty so that they have clear goal or purpose in mind. And the next, what indicators or variables do they need? Are those realistically available? And contrary to popular belief, or sometimes popular belief, it's definitely students think that all things are available, and it's just not going to be true. I have a colleague here in North Carolina, and she swears this is true, but she said that she once had somebody asking for the number of women who were journalists under a certain size, so who were considered petite for clothing sizes, because they wanted to open a petite active women's wear shop. And it was just, trying to talk through why that might not be something that is actually available to you, and what could be other variables you could use as proxies for what you're trying to measure. And then finally, what populations are you examining? What exactly are you wanting to look at, or who exactly are you wanting to look at, and is that going to be possible? And I often have discussions with students about protected populations, so prisoners and children and other people like that who are not necessarily going to have easily available data. The next one is who. And this is a critical one, especially for my reference interns. I kind of hammer this one home a lot. So the who cares question. Who cares enough about that specific question or that specific concern to spend the time and the money and the resources to gather that data? Who really will actually, because gathering data is a very lengthy process and it takes a lot of time and money, and who will really want to do that? And then in addition to that, if they have gathered all the data, are they expected or will they share it with you? So certainly certain areas, certain government agencies and things like that, you're definitely going to have an expectation that you might be able to get some access to some data, but you're not necessarily going to be able to do that with every institution. So I usually talk about the government agencies, the educational institutions, the organizations that would want to collect this information. And if you're not sure, the number one way is going to be a literature search of some sort, or looking at USA.gov or some other sites, portals like that, data.gov portals, where you can actually look and see who might be gathering this kind of information. The government statistical agencies are always a great point. And then the Statistical Abstract of the United States was, and still is now with its new owner, is something that we use a lot to try and isolate who actually cares about a question. And that, I think, the Statistical Abstract is the #1 most useful reference for most librarians when it comes to helping people find data and isolate the who cares question. So #3 is when. And to be honest, I think when is mostly about managing expectations. I often have students who are very disappointed that data for the most recent year or the past year are not available. And so we will have discussions about how data collection is a very time-consuming and expensive process. Sometimes data studies are grant-funded and the data collection ends as the funds go away. Grads, I think, tend to understand this a bit more, but undergrads in particular, in my experience, have had to have some expectation management when it comes to the time or the when of the data. In addition, so looking at the time frame that the data covers, whether or not it actually covers a time frame that makes sense for the student. If they're looking at something from the most recent year that they can get, so 2015, for example, might be a year that they could get, whether or not they can go back 10 years and look at older data and compare over time. And then also the periodicity. So is the data collected and disseminated every 2 years, every year, every month, hourly, right? Most students, I think, are willing to work within the limits that they have around them, but I think there's definitely something that that this is a period where you have to, or a point where you have to actually manage expectations a little bit. Number 4 is where. So this gets into the geographies or locations. Which geographies are most appropriate to answer the question? Are geographies appropriate to answering the question? Is it going to be something that is a geographical question, or is it something that's not? I approach geography in this particular instance from a very broad perspective, meaning universe. So this could be global, national, or even be looking at like individual high schools. So what exactly is the universe for the question? And then what geographic areas are realistically available? And we will talk about this a little bit more with the next slide. So you can see here we have, this is the census breakdown of geographic units. And it is possible to get to the block group level and the block level on certain questions, but the data becomes more and more difficult to use and work with as you're going to the lower geographic levels. And so talking about this issue, if you are using census data, that you'll run into as you get smaller and smaller, you have to use certain estimates to be able to answer questions. In addition, not all geographies are available for all questions. Again, the smaller geography it is, the more difficulty a student will have answering a question. Census tracts are readily available in American Community Survey, in a lot of other products, and we use these a lot and ask our students to think about these, using these. But they have in American Community Survey, they have those large margins of errors for many questions, and so it becomes a little bit trickier to use using the Census Bureau's tools. And so one of the things I do with students a lot is talk to them about other geographies that they can use and other ways of thinking about their question to get at the same kind of outcome. So for example, I'm working with a student right now who wants to look at immigrant communities, immigrant business owners along one of our streets, but it's very difficult to isolate individual data for that for obvious reasons. So we talk about census tracts and looking at the population of census tracts, an immigrant population or the demographics of those census tracts, and trying to understand those individual tracts along that road, as well as maybe doing a survey of business owners in combination with that. So the how. So how is this data collected? And this is a question we have to talk about a lot. So was this survey data? So was a survey created and disseminated, or is it administrative data of some sort where it's automatically brought in? How can that data, and then also secondly, how can that data be accessed? Does your library have access to the appropriate resources to be able to answer the question? I can tell you at UNCG we are now starting to buy a lot of things, but we used to have a budget problem, say 7 years ago or 6 years ago, and so we do not have a lot of the tools that are that make life easier for some people, and so we have to use what's available, what's freely available, and so we're constantly trying to figure out how we can access data and what kinds of data sources can we get to. And then there's the other question when it comes to access is whether or not it's freely available as a public use file, or if it's a data set that might require a restricted access agreement. And if it is, with our graduate students, especially and our undergraduates, trying to find public use data that would be much more useful for them, that they can actually use, rather than trying to take them down a restricted access road. So I'm going to switch over, and we'll see if this actually works. But one of the things I created for this is a list of links And I'll go back to the original slide real quickly. So if you do want to get access to this, you just go to tinyurl.com/datalinks-ALA 2017. And this will be available on the recording. You'll be able to see this too. But these are some links to various sources out there that I would encourage you to look at and to consider maybe joining in some cases. There are several organizations that would be helpful. There's tons of webinars, including a webinar that colleagues of mine did for SAGE a while back. And then also webinars brought to you by a series that's focused more on specific types of data access points. I've also created a list of the data archives. A lot of these data archives have freely available data so that you can look at those and see what's available for you. And then also research data management's a huge area. It's not something that we've pushed with our undergraduates per se, but definitely our graduate students at UNCG have been pushing this more. So there's some resources for helping you with research data management if that is something that you're interested in learning more about or that you need resources on. So that is me. I just want to say before I switch over that you know, the more knowledge we have about our data and what's available to our students, then we're going to be better able to lead our students to success. And so I encourage you to look through what's all available to you out there. And I'm going to hand it over to Diana. Thank you very much.
Hi there, this is Leah jumping in really quick while Diana gets all set up. I do have questions that came in. They're great. I've made note of them. We will address those in the Q&A. And now I'm very happy to introduce you to Diana because anytime I have a data question or anyone pretty much in our office does, she is the person that we go to. So I think you'll be in good hands, and thank you, Lynda, so much for that wonderful presentation. On to you, Diana.
Hi everyone, I'm Diana Aleman. As Leah mentioned, that was a lovely introduction. Thank you, Leah. So as she mentioned, I work on SAGE Stats, our social science statistical platform, and I've spent a lot of time working in data and extracting statistics from big data, cleaning data files into workable formats, and really assessing data and statistics for quality and relevance. And I've also had an opportunity to talk to a lot of the librarians and a lot of faculty, and what I found is that, as Lynda mentioned, students are just consistently being called upon to pull data and or statistics into their projects all the time. As we all know, data and statistics are just, you know, a big phenomenon that academic communities are recently absorbing and teaching students on. And I've also heard that from them that students are just having a lot of trouble actually understanding the data sets that they found and using it effectively in their projects or in the classroom. So today I'm going to go over some best practices on using data successfully after the research process is done. What are some practical steps that students can take not only in their projects but after college? Working outside in the real world, they're going to be confronted with data sets, data issues all the time. So I'll go over how students can really evaluate data that they found, preparing an explanation for the data as a piece of evidence, and best practices for data visualizations. So these aren't just applicable, as I mentioned, for academic purposes, but long-term habits they can take on when looking at data in the future. So for students, a lot of time, as Lynda mentioned, is spent finding sources and settling on the data set they think is relevant to their project. It can seem, after spending hours of looking for a data set or statistical table that's relevant to their project, that their work is done. I've definitely experienced that before. It can seem like you found the perfect source and you're just ready to go. But their work isn't quite done yet. Even after finding a data set that seems like a perfect fit, they do need to take some practical steps to ensure its quality, make sure that they can explain the significance and justification for using that data or statistics in their projects, and also really just determining the best visualization needed if that's required. So the first step I mentioned is to evaluate the data set for quality. A lot of times students will just get their data set and jump into it and play around with the values, trying to create charts, tables, and other visuals that they had imagined using for their presentation or project. Or, you know, more often than not, they just drop the data point into their papers without really a second thought. But as we all know, we can't really trust anything at face value, particularly data. We can't just trust it based on, you know, this looks right, this is relevant to the topic I'm covering, so I'm just going to use it, which I think is a tendency that students tend to have. So because of that, it's good practice just to take a step back, to teach students to take a step back from that urge to rush in and really take some time to assess and evaluate what they've found. So the first question students should ask of themselves is, do I actually understand what I'm looking at? Do I understand what the data is saying? So most statistical and data sources do a decent job of providing variable information alongside the actual data points to describe the topic of the data set, the unit of measure, the time period that's covered, and so on. But this isn't always completely clear and understandable just because of the big, messy nature of data and even aggregate statistics, as Lynda mentioned. She mentioned the American Community Survey, the ACS, from the Census Bureau. And if you ever downloaded, you know, one of their massive tables, it can be pretty intimidating, especially when you're just looking for a handful of statistics on, you know, educational attainment or something like that. And it's also partly due to general student inexperience. If that is the case, then they're just better off finding statistics, basic statistics through literature research that are more appropriate to their level of understanding. If they do have a good grasp of what they're looking at, then the next few questions will help them get a feel for the quality of the data set. So where's the data documentation and what does it reveal? So data documentation or data notes can really come in the form of a data dictionary, full methodology notes, or somewhere in between. And it's a lot like fine print. It can be really technical and really no fun to read unless you're looking for some additional information. But you can learn a lot about the limitations of the data based on how the information was collected, the definitions for the topics that are included, and so on. So, for example, finding out that the data set you have is supposed to represent, you know, 10,000 people, but is actually based on a sampling size of 10 survey respondents, is something that you'd probably find in the data notes, and could help make you reconsider and hurt your perception of what you found as a solid source. So when looking at the data set, when actually diving in there, there are some red flags that they should keep an eye out for. For instance, are there missing or suppressed values? And this is particularly true of you know, health data sets over privacy concerns. Most of the times those values will be flagged. Have the variable descriptions changed between years? This is common with survey data where wording of a question may have changed in between survey years. What geographic boundaries were used when collecting this information? If you're looking at, you know, metro areas, these can change drastically. The demographics and the actual boundaries of a metro area can change drastically over just a few years. So these kinds of questions are a good starting point for a student to evaluate the data set and just forces them to consider how factors like these influence the data they plan to use in class and their projects. In most cases, a good source will provide the data documentation, but students should learn to ask these questions of the data set that they collect and not just rely on the assumption that what they found is good to go. So I mentioned red flags, and I wanted to list some common ones that I have come across and that students should also keep an eye out for when evaluating a data set. So empty value fields. Does the data documentation explain if these are zeros, or are they actually missing, or are they suppressed? If they are missing or suppressed, then why are they suppressed? So, for example, the screenshot to the right is some police shooting data from the Washington Post that I had considered pulling into our Sage Stats collection. But I noticed when I was evaluating the content that there were more than a few blank value fields, which are highlighted in yellow in the age and race fields. It's not totally unreasonable given the state of data collection on this particular topic that these are, missing, but it did indicate that the data was somewhat incomplete, and it was enough to really consider waiting for a more complete data set from a more formal study, which is forthcoming from the federal government, I believe. Second, misspellings, particularly if data is categorized by location, company, or so on, is another flag. If the spelling is just not correct consistently, then it's information that may be prone to human error. Value outliers are also something to watch out for. Outliers are pretty common, but students should consider how the outlier makes sense in the context of the data. If you are looking at, housing prices in a particular area and you see that the data ranges from, $100,000 to $200,000, and then you also see one value that's, over $2 million, then that's a flag, something to look into a little bit further. Finally, duplicate records are another flag, and this one is a little bit more worrisome. Multiple values assigned to the same person, for example, would be confusing and clearly wrong for whatever reason. So these, as I mentioned, are some flags that I found across many data sets, but it doesn't really cover everything. Generally, if a student comes across anything that looks odd or out of place, then it's best to just delve into it a little bit further, ask the source additional questions, look for the answer in the data documentation, or even reach out to the data collectors themselves. So just going back to my Washington Post example, you'll notice that on the left-hand side, I highlighted TK in the name field, and the Post notes didn't really explain what TK meant, but some internet sleuthing on my part told me it means TBD. So that was just another thing that concerned me a little bit and hinted at the data set as incomplete, but still pretty impressive on the part of the Washington Post. So flags like this don't necessarily immediately mean the data set is unusable, but that it deserves a closer look. So all that work that goes into evaluating a data set will better enable a student to explain and justify why they are using that particular piece of evidence, why it's the best evidence for their argument. Of course, they don't really need to go into too much in-depth explanations. They don't need to write up a summary of the technical notes, the data documentation, but they should be prepared to just concisely and clearly explain their thinking to faculty or TAs who are looking at this information for the first time and may raise some questions since faculty and TAs have a bit more experience on using data sources for their own research purposes. So asking the following questions is a good starting point. How does this data set support or oppose my argument? This is obviously a pretty fundamental question students will be consistently asking themselves as they come across researching or coming across data sets or researching data sets for the first time. But it's really worth repeating after having evaluated the data set that they've settled on, which may have revealed some inconsistencies. Really, whether it supports or opposes the argument is okay either way. If the data opposes the argument, then it perhaps shows the student that their original premise needs to be changed, or at the very least allows them to use it as evidence in a counter-argument that they really should address anyway. Second, why this particular data source? Students will come across a lot of sources covering the same topic, but with different values. This question forces students to consider the reliability of a source and how the choice of source can affect the data that they found. So being able to explain their choice to faculty really demonstrates a strong level of understanding about the data and the topic. And finally, a student who can really identify the data consistencies or flags that need to be made transparent to the reader can more successfully defend their evidence and check any doubts on the part of the grader, because a successful argument doesn't ignore data inconsistencies by talking around them or leaving them in the dark. They're addressed and brought up immediately for consideration. So just an example of why students should consider their choice of source. I've pulled some 2016 unemployment numbers from the ACS by the Census Bureau and the Bureau of Labor Statistics. Both are considered, pretty reliable go-to data sources, but you can see in the highlighted fields that the values for unemployment are different. And although they both release unemployment stats, their methodologies are different and really results in different numbers. So knowing the difference based on the evaluation and being able to explain their reasons if asked by their professor for their particular source, again, demonstrates just a higher level of knowledge of the content, data, and their argument. So I also wanted to briefly touch on data visualizations because it's a topic that just comes up a lot when talking with faculty and librarians. For students who have projects with a visual element, the number of options out there is really overwhelming. Should I stick to a basic table, a chart, a map? So I have some basic recommendations and tips on how to go about determining that. So the great thing about today is that we're all data visualizers thanks to Excel. You're more advanced or creative student or researcher or designer may want to create a really beautiful chart from scratch. But there's nothing wrong with the traditional charts that a novice student may feel more comfortable with, just to avoid any misinterpretation of the data statistics they have. Bar graphs and pie charts are really good for categorical data like race, eye color, economic industries, and so on. So long as pie charts add up to a specific value like 100% or total budget for a fiscal year, something like that. Line graphs are great for measuring variables across time like years. And scatter plots are a good way to observe correlations, measure relationships between variables. And although Excel doesn't support geographic mapping, I added it because visualizing data by location helps readers just more quickly contextualize and understand the data than your typical chart format. And finally, just some additional tips that I think students are probably aware of but should aim to follow consistently are shown here. So keeping it clean and clear prevents confusion. if there are a lot of colors going on and different shapes and a lot of different variables being included in the chart, then the reader is going to have trouble immediately understanding the significance of the graph's message. Also, consider your audience. A playback of how data changed over a few years might be more engaging than your standard line graph or table. And one of the more important things is to cite the visualization in detail. There is nothing more frustrating, particularly to me, than coming across a really cool data visualization only to find that the citation isn't specific enough to pinpoint exactly where the underlying original data lives. So, for instance, there's a lot of news reports and accompanying visuals on the drug and opioid crisis going on right now, including this one from the New York Times. The source line really only lists the National Center for Health Statistics and the CDC. And as most of us may know, those are massive organizations that publish lots of information monthly, if not weekly, if not daily. So a direct URL or a specific report name even would be a massive time saver for a student who, is doing some firsthand research on getting a grasp of the opioid crisis and being able to find the data and who are interested in using the data for their own projects. And also just not to mention the confusing kind of formatting of this graph. Why are some lines blue? Why aren't the others blue? Wouldn't it have just been a little bit more straightforward to make it a comparative bar graph showing how the values changed from 2015 to 2016? That's just me maybe though. So overall, the thing you want to avoid is information overload. If the message of the significance of the data isn't understood or captured within a minute or two, then it's just way too complicated. So for instance, looking at this map of East Coast counties who received FEMA dollars after Hurricane Sandy hit in 2012, I think does a pretty good job of helping the reader immediately identify areas that were impacted by the hurricane and received the most help from the government. So although a table would be equally informative, the map format allows the reader to just more quickly absorb the information while also keeping it clean, simple, and visually engaging. So that was a lot of information, and I touch on a few of these areas in my blog on Sage Stats. So if you have, any interest in reading more tips, please check it out. And I think I'll turn it over to Leah for any questions you may have now.
Yes. Thank you both so much. We did get some questions in, but Lynda and Diana, I just want to say that was very informative and we appreciate it. We're going to spend some time addressing specific questions from our audience, but I also wanted just to let you know if some of you have to drop off, we will be sending out, emailing you a recording of this, and we also are going to, everyone that signed up for the webinar is going to be invited for an extended 60-day trial with Sage Stats. So if you want to take a look at that and try that out, we're giving everyone that called in, instead of a 30-day trial, a 60-day trial. So that'll come in an email to you very soon. The first question we had came from Megan Lowe, and it was for Lynda. And it says, when discussing the how often do questions of authority and credibility arise?
That's a great question. A lot of times, and that's one of the things that we talk about a lot. So I'll give you an example of that. One of our resources is, let's see, I'll not name it, but I'll give it an example. It tends to bring together a lot of government sources to make very usable and visual data. It visualizes things for you. But it doesn't really tell you how it's bringing those sources together. So it will bring together, FBI data with crime data and all these different kinds of things together and mash it together, and you don't really know what how they're doing, what the methodology is, and that is one of the difficulties we'll talk through. Kind of, well, this is an issue that you'll run into with this kind of aggregator source, but you know that the original source it's coming from is the government, and so we can say some things about where that original source is, what that original source is, but also talking about what you're really needing for your research isn't to do high-level data analysis. It's just really to get a snapshot of the community that you're looking at. So this can still give you useful information based on kind of the original source. But we have had a lot of students, there's concerns about, of course, some government data either not being available or going away, and just talking through kind of what is involved in the data collection process, and how can you, who to be looking for in terms of the institutions that have the money and the institutional framework to be able to gather data, how you can kind of triage, look at multiple data sources like Diana was talking about in her presentation, to understand not only the methodology but also kind of fact check the data and make sure that it's actually giving you reliable information. Most of my students until recently were they kind of took the government data for self-evident, and so I know that now there's been a little bit of a questioning. There's been a process of questioning some of that data that we're seeing, which is unfortunate because I think a lot of those surveys are still really good, and a lot of the surveys are legitimate, so that we shouldn't encourage them to question. Or no, that's not the way to put it. We should encourage them to question and think critically, but to also understand that there are frameworks in place, there are institutions in place that can gather really good data, and you should use those. That was a very long answer to that question.
It was great. Thank you, Lynda. The next question came from David Isaac, and it said, Lynda, you mentioned that you use the 4W1H framework for teaching library reference interns. Do you also use it when doing data instruction in the classroom?
Not explicitly as much, because I'll integrate those concepts into, actually, no, that's not true. I just recently in one of my classes, it's sociology class, started using that framework, not for data, but actually for getting them to think through their research questions. So they have to come up with a question that can be quantifiable, that they can use quantitative data in. And so I actually had them do this very similar thing during the research, during the library instruction session, to think about what's the who, what's the what, what's the where, what's the when. And I didn't even realize until after the fact that I kind of had done used that framework. For me, it was just a really, because they need those elements to be able to answer a research question anyway, and it kind of was the data coming into the library instruction session. So yes, it can be done in the library instruction session, and I think it makes it a little more, some of the projects they may be doing a little bit more manageable in a lot of ways. But it works really well with interns as well, so I encourage you to feel free to use this.
And we're almost out of time, but I have a question for Diana that says, some undergrad students have geographic statistics that they want to map out. What programs can they use to do that?
So that's a great question. If they have their own data set that they'd like to upload, I think Tableau comes highly recommended from everyone. I also really enjoy how sophisticated the end visual product turns out. If they want to just, pull a map from a database, there are multiple products out there like Sage Stats or like Data Planet, which are also available. But Tableau is freely available in its public version, so I definitely recommend that.
Great. And then another question from David Isaac for both of you. And I think this is a great question. How do you express to undergraduate students that finding data and familiarizing themselves with data may take longer than they expect?
I think that kind of goes back. Oh, go ahead, Lynda.
No, go ahead, Diane.
I was just going to say, I think that goes back to Lynda's recommendation to set expectations. Working with data is just one of those things that it's always going to take a few hours depending on your research question and your data needs. So I think talking it out with the faculty member or your data librarian will give students a better idea of how long the process will take.
Yeah, that's my experience has been really making sure that, and in most cases this happens, that the faculty member brings them, if they're going to bring them in for the library instruction, that they bring them in early enough for that kind of question, so that they're, or that kind of research, so that they're not kind of encouraging them to start. It's not that they're necessarily going to start at that time, so if they come in the first month, they're not necessarily going to start on the project that time, but I do, in my library instruction sessions, leave a lot of time for them to work one-on-one with me and to do searching as possible. More than showing them sources, I will give them the, those questions to think about, or ways to think about their data, or think about their questions, and then time to actually do some discovery in the session. And I think that helps to at least get them started on the process so that they understand it can take time.
Great. Well, I think that's about all the time we have for today. Thank you everyone for joining us, and a special thank you to Lynda and Diana. In the next week or so, look for an email that includes the link to view the entire webinar and slides. We'll answer some specific questions, and we'll also send you a special invitation for that extended trial to Sage Stats. And please stay connected with us on our blog, Sage Connection, for information about upcoming webinars. We appreciate you being here, and thank you very much.